You think it's nap time?
I'm sorry, but you cannot nap.
Mm.
Nap time, we don't need it when we're like small.
Right? I feel that.
Yeah, I would like daycare. They only take us to nap because not TV, not just watching the TV.
Yeah. Hey, Algebra 1, Thursday, 30th of this 2020. SWBA. Actually, that's wrong. Students will be able to. It's going to be use and apply properties of exponents. That's wrong. I ooped. Okay. So, exponent properties involving products. So, first of all, I'm going to write my name on there. Me llamo Señor Castle. Mr. Señor Castle. Señor. Spanish. Okay. So make sure you have your name on there if you don't already. Okay. Is this big enough on the screen where you guys can read it?
Yeah. No, I need a bigger.
Not for you? Is that what you said?
I can't read the numbers.
Okay.
That's why you have it in front of you.
Okay. All right. That's good to know. Yeah, because this is really narrow. Okay.
You have it in front of you though.
You do have it in front of you, yeah. But it's still good to know what I'm writing. So it's all tough. Okay. Well, I might have to work with that a bit. I'm not sure why it makes it so narrow on the setting. No, I can't because what's happening is the projector is just making it only on this space. So this is as wide as the projector's getting. So it's a projector issue. I could, but then you only see like this part of it, kind of thing. So it doesn't make it any bigger on the board. It's the picture's still going to say this big. You would just see less of the picture because you see more of it zoomed in. Like that. Oh, that's zoomed in on mine, but not on yours.
Boo, get a different.
Get
a different projector.
Yeah. Yeah, I could zoom on the projector a bit. But then I couldn't scroll around. We're going to continue like this the best we can. Okay, Lauren, can you read it or no?
I can see it, yeah.
Okay. So, exponent properties involving products. Okay, products is what type of problem? Multiplication problem, right? Okay, products are multiplication problem. So, important notes, guys, before we get started. A variable is a variable without an exponent. If we see a variable or a number without an exponent,
1.
It can be written as a power of 1. So if we see like an x, it's really the same thing as x to the first. Or if we see a 3, it's the same thing as 3 to the first. Okay? Because there's one of them. There's one of them being multiplied together. It's just one.
You can't write 0 because that would equal 1.
Yes. Okay. So a variable without an exponent is the same thing as an exponent of 1. And then the parentheses are important. We talked about that during our warm-up today. Okay, that negative 3 squared is different than negative 3 all being squared. This one ends up being like a negative 3 or negative 1 times 3 times 3. So this one ends up being negative 9. And this one ends up being negative 3 times negative 3, which is positive 9. So this all just depends on where that parenthesis is, right? On where that negative is too and where the exponent is. So the positioning of it. So we're going to have 3 rules today we're going to go over. Our first rule is going to be product of powers. Product of powers. And what this is saying, guys, is if we have any variable a, any number a, this is representing a number, okay, raised to the power of m, to the mth power, so to speak, like the 4th, 5th, 6th, mth, okay? And we multiply that times the same number to another power n. Okay, notice these are the same number, they're the same base, okay? A reminder, we call on exponents, we would call this, if we have like 3 squared, the 3 is the base, and the 2 is the exponent. Okay, a bit of a reminder there. The 3 is what we call the base, okay? And the 2 is what we call the exponent. So if we have the same base a raised to the power m times base a raised to the power n, we end up saying it's the same thing as doing a to the m plus nth power. You add them. And let's do some exploration to kind of look at this. There's an exploration there, okay? So we're going to write in there is we're going to say, okay, well, let's say we have a squared times a to the 4th. So So go ahead and write down there a squared times a to the fourth. Okay. And we're going to say that's the same thing as, well, a squared is how many a's being multiplied together?
2.
2. So it's the same thing as a times a. That's the same thing as a squared. A times a is the same thing as a squared.
Don't work this.
Okay. I do want you to write this. Okay. Oh, not equal, excuse me. I wrote the wrong stroke. And then a to the fourth is how many a's?
4.
4 of them, right? So that's going to be 4 a's. 1, 2, 3, 4 a's. That's our a to the fourth. So now we have a squared times a to the fourth, right? Right, Elliot? Yep. So if we were to go through and count the number of a's, how many do we have multiplying together there? 6. So that's the same thing as a to what power?
6.
The 6th power. That's the same thing as a to the 6th power.
But wait, why does it say m plus n?
Okay? M plus n and n are just representing numbers. So in this case, m is 2, n is 4. But hey, if we just take out this middle step, if we kind of go straight from this first part over to the third part here, what did we essentially just do with our exponents? Add them, which is what the rule is saying is true. Okay, that's just what the rule is saying is true, but this is why it's true. We say, hey, we notice this pattern here. It ends up being that way all the time, and so that's why it's true this way. Okay.
You need to stop putting 1 halves.
Yeah, I know those copy weird, don't they? Okay. So we have a squared, a to the fourth. Because we have the same base, we can just add the exponents and have a to the 6. Okay. Ooh, that's not what I meant to do. Okay. So when we multiply terms with the same basis, we do what with the exponents? Add the exponents. Want to write that in?
What if we have different?
Then you can't. We'll talk about that. All right. So we're going to work on with a couple examples here. So we have a to the 5th times a to the 7th. That's what those parentheses next to each other mean, is that we're just kind of multiplying those together. So we have the same base a being to two different exponents, 5 and 7. So what does that end up being?
12.
A to the 12th. A to the 12th is what that ends up being. We add the exponents. That's what our rule says there. So we're going to practice just that. If we wanted to write all of them out, if we wanted to write 5 A's out and then 7 A's out and then count them all up again like we did in our exploration, you could. That's a lot of work. Okay. So, and a lot of time, okay, and a lot of writing, okay? Questions on that of why their first example ends up being a to the 12th. Okay? Do we know what a is? Do we know what number that is? No, so we can't simplify it anymore. If this was 2 to the 12th, could we figure out what number that is further? Yeah, you could actually do that operation, but we can't with just a. We don't know what it is. Okay? Well, how about on example 2? X squared y, xy to the 4th. X squared y, xy to the 4th. Okay? Well, there, how many different bases do we have here?
2.
2. We have both x and y, okay? And we have x squared y. What's that y being raised to, that first one?
Nothing.
Power of 1. If you don't see anything there, there's an exponent of 1. We can write that in there if we like. You don't have to. Okay? What about that next x? What power is that being raised to? The first power as well. We can go and write that in there too if we would like. Okay? And then we have y to the 4th. So I just put power of 1 there. Okay? So now, if we were to go through, okay, if we want to, we said that we can rearrange multiplication. It doesn't matter the order we multiply things in. We can do 3 times 2, 2 times 3. It's the same thing. So if I wanted to, I could rearrange this and go and put my x's together. And I could do x squared times x to the 1st, y to the 1st, y to the 4th. I could rearrange these things because everything's being multiplied together here. All 4 of those parts are being multiplied together there. So if I want to rearrange it and do my x's first and then my y's, I totally can.
Just make sure you don't put an x, comma, y.
Okay, yeah, just make sure we're not doing commas, right? Okay. So now, what's x squared times x to the 1st?
X to the 3rd.
X to the 3rd. We add the exponents. What about the y's? We
X
get
to the 5th.
try again. Y to the 5th. So we end up getting x to the third, y to the fifth. And that's our answer. Because our x and y the same base? Are x and y the same base? No, so we can't add those exponents. Those stay how they are. Okay? As long as it becomes xy to the eighth, you don't add those exponents anymore. Only can do that if they are the same base. Okay? Questions on that one, on how we got that as the second one. Okay? Now, as we get into this more and more and more, guys, we're going to see we don't even have to rearrange it. This middle step I did, this step right over here, okay, that I just drew the arrow toward, we don't actually have to even do that step. If you want, and you can just see here in this original, we're multiplying all four of these things together. And you can go through and say, okay, x and x, 2 and 1, x to the third. Y and y to the first, y to the fourth, y to the fifth. Boom. You can go right to that answer if you want. Let's look at example 3 here, okay?
I think I know your problem. Created with doc tree is taking up too much space.
No, I don't think that's the issue. But thank you, though. I appreciate the input. Okay? On number 3, 9y squared times negative 2x squared y cubed times 1/2 xy to the fifth. Now, is that 1/2 showing up very well on yours? No, go ahead and write in 1/2 right above that, just so we know what it is.
Stop doing that.
Okay. Okay.
Please, stop doing that.
So if we follow the same pattern we did on number 2, we would reorganize everything to be next to each other, right? For like things to be next to each other. So I would put the coefficients first, right? I'd probably put those coefficients, those numbers first, because those have to multiply with each other. So I'd have 9, let me try that again. 9 times negative 2 times 1/2. Then I'd probably try and put my x's first, right? And then I'd probably try and put my x's next. So what am I going to put next after that 1/2?
All your y's.
My x's?
Your y's.
Let's go alphabetical.
No.
Okay.
The opposite.
Let's do it anyway.
Please. X squared.
X squared and then x. Very good.
Wait, do we have to put them all together?
Okay. Well, we're just doing this in between step. You don't have to do this after a while. Okay. But for starting, I think it's good to do. Okay. Then what would I do after that? I covered all of my x's.
You did 2x to the fifth.
There's no x to the fifth.
Why?
What do I do after I cover my x's? I do my y's. So I have y squared, then what?
Y third.
Y cubed, y third,
And y to the fifth.
and then y to the fifth. Now when I have it like this, it might be easier for me to see what's going on. Okay, it might be easier for me to see what's going on. Maybe it is. Okay? So we can do those numbers out in the front. 9 times negative 2 times 1/2. What is 9 times negative 2?
Negative 18.
Negative 18. Negative 18. Okay, what's negative 18 times 1/2? What's 1/2 of negative 18? Negative 9. Okay, if you need to do it off the side, negative 9 times 2 is negative 18.
18.
Times 1/2, yes. Ends up being negative 9. Okay, how many x's do we end up having?
3.
Okay, x to the third,
10 y's.
and then y to the 10th.
That's too many.
Can we do anything more with that?
No.
No. Cannot.
Numbers maybe.
Okay, if we had numbers, yeah, we totally could, but we don't. Okay.
Unless it was pi.
Questions on that?
Unless it was pi.
Okay. Now, can anybody think of something we could have done to make this maybe make the math a little easier on us?
Not do any of it.
What about if we had multiplied the numbers in a different order? Those first two numbers. Could we have done 2 times negative 1 or 2 times a half first?
Yeah, negative 2.
Yeah, you could have done 2 times a half and gotten, or negative 2 times a half, thank you, and gotten negative 1 and multiply that by 9 if you wanted.
Or we
Okay,
just-
so you can think of patterns that way. You can do group things. Okay, and once again, do you have to do this step in between the two?
No.
No. Okay, once we get good at these, once we practice more and we get more used to them, okay, you don't have to do the step here of rearranging. You can go through and say, okay, as long as you multiplied everything together, as long as you took care of or counted in every single part here, you're good to go. Okay, so if you see everything's being multiplied, x squared, x to the third, okay, and then count up your y's, same thing.
We did this last year.
Okay, questions on that? Yes, Reese.
Were you only doing the first basis there?
Yep. Okay, continuing on. Let's go to the next rule. Okay. Rule number 2, power of a power. The first one was product of powers, so multiplying and exponents. This is power of a power. It's an exponent raised to an exponent. So we have a to the mth being raised to the nth. A to the mth, which is being raised to the nth. And when we say mathematically, it's the same thing as if we were to take a and we were to multiply those two exponents together. If we were to multiply the two exponents together, it'd be the same thing mathematically. So let's look at an exploration with this. So if I deal with the same numbers, a squared, and I raise this to the fourth. Yep, a squared in parentheses, and I raise that to the fourth. Okay, so let's go ahead and write that down there. A squared, and we'll raise that to the fourth. Okay. Now, to the fourth, how many then, what's that telling us? What's that exponent of 4 telling us? Okay, there's 4 of whatever's inside the parentheses being multiplied together. So what are there 4 of?
2 and 8.
Of a squared. So I'm going to have a squared times a squared times a squared times a squared. That's what that's saying. It's the same thing as a squared being multiplied together 4 times. So let's go ahead and write that in there, please, for our exploration. A squared to the fourth is the same thing as a squared times a squared times a squared times a squared. Okay? So now, according to rule number 1, Bailey, how would we handle those exponents? All those 2's? No, we don't multiply them. According to rule 1, we'd add them. And we'd end up getting a to the what power?
A to the 8th.
Okay, a to the 8th. Okay, we end up getting a to the 8th power. Yep, a to the 8th power, okay? And we say, okay, well, if we were to... Yes? Okay. If we were to have gone straight from the first part to this third part here, like that, well... Yeah, just enough. Yeah, I'm gonna have to get more. Right. So if we were to have gone the first part to the third part, what would we have done with this exponent of 2 and the exponent of 4 to get 8? Nate. What would we have done with these two exponents, 2 and 4, if we were just going straight from the first to the third part? Multiply them, which is what the rule is saying. Okay. As whenever you have a power raised to another power, you end up multiplying the exponents. And here's the math, the exploration behind it is all those a squareds being multiplied together. Okay? So when we raise a power to a power, we blank the exponents. What's the blank there?
We multiply.
Multiply. We multiply the exponents. Okay? So example 1, Elliot, what would you do? Yep, and you get a to the 15. Thank you, Elliot.
You're welcome.
Okay, I want you guys to do number 2 on your own. When you guys do number 2 on your own, when you have it or have questions, raise your hand. When you have it or have questions, raise your hand. Do you want to help me check? Okay. Very good. That was right. Do you want to help me check, Reese?
What?
Do you want to help me check? I felt your pass, yep. Hey, borrow one from my friend. Yep, that's good. Yep. Yep. Okay. So what do we end up getting here? X to the 12. Very good. We multiply that 4 and the 3. Okay. And if we were to go the long way again, which you always can do, it'd be x to the 4 3 different times. And we say, okay, well, we need to multiply or add the exponents to get x to the 12th. Okay. But once again, you don't have to go that long way once we know these rules. Okay, let's get number 3. 2 to the second to the third. Lauren, you have it? Okay, what did you do? What did you get?
64.
Okay, and how did you get that?
I did 2 to the second 6 times, and then that was 2 to the 6th power.
Okay, so I'm going to pause you real quick, okay? So Lauren said, hey, 2 to the second to the third, that's 2 to the 6th. Because we multiply those exponents. Okay, and then?
Since 2 can go into 6, it can go into the 6th power, and go to 64.
Okay, so we end up multiplying 6 2's together, okay? And since we actually know what 2 is versus x or a, we can actually do that math. So I would encourage us to do that math. So do 2 times 2 times 2 times 2 times 2 times 2. We probably don't know 2 to the 6th off the top of our head. Okay, we can say, okay, what's 2 times 2? What's 2 times 2? What's 2 times 2?
4.
And these are still multiplying together. What's 4 times 4?
16.
What's 16 times 4?
30.
That's where we end up getting. Okay.
34.
What's 4 times 6?
44.
Haha. What's 4 times 1?
4.
Plus 2?
6.
64. Lauren was right. We end up getting 64. We end up getting 64 as our answer. Okay. Questions on that? Okay. Yep, always. Okay. Questions on that one? Okay. Let's go ahead and continue on then to rule number 3. Let's keep trucking along, guys. Power of a product. Okay. So we're taking a product and raising it to a power. So here we have the product A times B. Any two numbers, A times B. And we're raising the whole thing to the power of M.
Is this a math tripoint?
Okay? No. Okay? And so what we're going to say is it's A to the nth and B to the nth. We end up putting both of them to the nth power. Okay? And we're going to talk about why that is with our exploration. Okay? So let's say we have A times B squared. And the squared is just on the B there. So let's write what I have real quick. A, B squared in the parentheses. And then we have the whole thing raised to the third power. That whole parenthesis raised to the third power. The exponent of 2 is just on what variable? The B. It's not on the A. But what about the exponent of 3?
It's on there.
That's on everything, okay? So that's telling us we have 3 of what?
4.
B.
AB squared. So we have AB squared times AB squared times AB squared. We have 3 of whatever is inside that parenthesis. In this case, it's AB squared, right, Bailey? Right, Bailey? Yeah, okay. So we have 3 of AB squared, okay? So let's write that out. Okay? So then, well, according to rule number 1, what do we end up doing with all those A's? We get A to the
30.
third and B to the
6.
6. And that ends up being our answer. So for this one, if we went straight from the first to the third part, we took out the middle, and we just try and use rule number 3. What we end up doing was we took A to a power of 1, B to a power of 2, and we multiplied the exponents. So this 1 times 3 is 3. This 2 times 3 is 6. And that's how we get those exponents. That's how we get our new exponents, okay? This is kind of like repeating rule number 2, isn't it? It's kind of like rule number 2 just on repeat. Okay, it's like rule number 2 on repeat, kind of like Africa by total on repeat, okay? It's just rule number 2 on repeat, okay? Please don't tell me to shut up, okay? Okay. So rule number 2 is kind of just on repeat here. So instead of just multiplying the exponents to one of the things, you have to multiply it to everything inside, all the exponents inside. even this invisible exponent you don't see. So that's how we get a to the third, and it's not a to the fourth, something like that. A common mistake is that we add those. So when we raise a product to a power, we distribute the exponent. Now we only do exponents to exponents. We only multiply the exponents together. We do not multiply the exponent with the base. I'm going to say that again. We only do exponent times exponent. We do not do exponent times the base. Okay? So on example 1, x squared y all being raised to the fourth, or the quantity of x squared y being raised to the fourth. Anyone have an answer on that one? They think they have? Okay, Christian?
X to the 8th by y to the 4th.
Yeah, x to the 8th, y to the 4th. X to the 8th, y to the 4th. Very good. So we end up saying, we take that 4, that's on the outside of the parenthesis, and you multiply it with a 2, and this y to the 1st, that we don't see the 1 there. And so we go x to the 8th, y to the 4th now. Okay? On example 2, okay, raise your hand if you think you have an idea what we can do on there. Okay, Seth?
You would have 2p to the 9th and q to the 6th.
Okay, I almost entirely agree.
To the 8th.
Okay, nope. You have the q should be to the 6th. Okay, we do the 2 times 3, we don't cube it. Okay, we do 2 times 3. So I agree with Seth on the p's and the q's. What power is 2 secretly being raised to?
3.
The first power, so now it's being raised to the third power. Okay, so inside the parentheses, originally, that 2 is secretly being raised to the first power. So not only do we have to make sure we multiply this exponent to the p and the q exponents, we also have to multiply it to the exponent on the 2. We can't forget that. It's a very common thing that we forget that. Or it's a very common thing to multiply just 3 times 2 and get 6. But in reality, what is 2 cubed? What is 2 to the third power? 8. This ends up being 8p to the 9th, q to the 6th. And that is our answer. That is as much as we can do there. Okay. Question on that? Okay. Well, let's look at example 3 here. Example 3, is there kind of a lot going on right now? Yeah, we say there's a lot going on right now, okay? It looks like we have 2 of these kind of stuck together. Like 2 of example 2 kind of stuck together. Well, let's say we just cover up the right parenthesis right now. Let's just say we cover up the right parenthesis right now. We pretend that one doesn't exist. Can we do the left parenthesis? Yeah, let's go ahead and do that left parenthesis. Okay? Reese, you want to help me with that one?
Yep.
Okay?
So it would be 3 to the 2nd,
Okay?
then g to the 6th,
Yep.
and then h to the 8th.
Very good. Okay? So we end up getting 3 to the 2nd, g to the 6th, h to the 8th. Reese did a really good job making sure he did not forget about that 1, the exponent of 1 on the 3. Okay? And you remember to multiply that 2, the exponent of 2, that's all being raised to there as well. Okay? So that's the left parenthesis.
What about the 3?
Okay? The 3 squared?
Yeah,
We'll finish that off in a second. But now, let's take a pause and let's go to the right parenthesis. 2g, h to the 5th, all to the 4th. Somebody want to help me with that one? Justin?
2 to the 4th, and g to the 4th, and h to the 20th.
Exactly right. 2 to the 4th, g to the 4th, h to the 20th. And Justin did a very good job as well, just like Reese did a moment ago, of saying, hey, this 2 is being raised to the first power. So we need to multiply that 4 to all 3 of those exponents. So now we can go through and we'll continue on with the left parenthesis. What is 3 squared? Because we can still do that exponent. 9? So you have 9, g to the 6th, h to the 8th. Okay, what about 2 to the 4th? Okay, 16. If we need to write that off to the side, please do. If you need to write that off to the side and say, okay, 2 times 2 times 2 times 2, 4 of them. 2 times 2 is 4, 2 times 2 is 4. That's 16. I don't understand. 16, g to the 4th, h to the 20th. Oop, I shouldn't have that in orange.
doing?
Now, what can we still do?
Nothing.
We don't call them combined like terms, but we'll multiply together, okay? And we'll end up multiplying those constants, we'll multiply those the same bases, okay? When we say combined like terms, that gives us the connotation that we're adding and subtracting, okay? We mean adding and subtracting when we say combined like terms, but I completely get what you guys are saying, because we're going to multiply the coefficients together, you're going to multiply the g's, you're going to multiply the h's, okay? So you guys meant the right thing with that, okay? So yeah, 9 times 16 is a pretty big number, okay? Well, let's figure this out. Okay. Well, hey, first, real quick, is 9, what number is close to 9 that's really nice to multiply with? 10. 10's pretty close to 9, isn't it? How far off is it? Just by 1. Okay. Well, hey, what's 10 times 16? If we were to say, instead of 9 times 16, 10 times 16 would be 160, okay?
Just take away 6.
And then, how many extra did we just tack on there? We tacked on 1 extra 16. So we say we only want 9 groups of 16. Right now we have 10 of them.
Take away 6.
So we can take away 16 and get 144. Okay? And we'll see that actually ends up being the same thing. I'm just trying to teach you guys some mental math skills there. Okay? But 9 times 16, 9 times 6 is 54. Excuse me. Yep, 54. I don't know why I blinked there. 9 times 1 is 9, plus 5 is 14. So it ends up being 144.
Why are you going blank?
I don't know. Okay? Can anybody help me finish it off with the G's and the H's, though? Okay? Can anybody help me finish it off with the G's and the H's? Okay, go ahead, Nate.
G to the 24.
Ooh, not quite. Okay, so we're multiplying the bases. So what do we do with the exponents? Add them. So it ends up being G to the what? Good redemption. And H to the 29th. There you go. So 144, G to the 10th, H to the 29th. Okay?
What is this?
Any questions on that one? All right.
What is number 24? What is number 4?
Okay. Ends up getting a little bit. We got a little bit more here. Okay, we got a little bit more going on. That's a 1/2 again, guys. Okay? 24x squared y, 1/2 xy cubed, all to the third.
Everything. Well, not everything.
Okay? So make sure to write it in that 1/2 here. Doesn't come across very well in your guys's.
Yeah, I've never done it.
No, it doesn't. Okay? Well, what can we do? Can we do anything in the first parenthesis?
No.
Okay, we like to follow order of operations, guys. Order of operations. PEM does parentheses first. Okay? We can't do anything inside the first parenthesis. Can we do anything inside the second parenthesis?
Yes.
We can?
Yes.
What can we do? Okay, so that's not inside the parenthesis. That's actually dealing with the exponent, though. Okay, so actually, if we just look only inside the parenthesis, we can't do anything. So then we move on to exponents. Okay, left to right, exponents. X squared. Can we do anything with this exponent of 2? Nope. Y cubed. Can we do anything with this exponent of 3? No, but can we do anything with this exponent of 3 on the outside? Yes. So that's our first step.
Make sure you don't put it in both of them.
Okay. Yep. Make sure we only do it to the second parenthesis, right? Not the first parenthesis. Very good. So the first parenthesis will actually stay the same. 24, haha, x squared y. And the second parenthesis, well, what is 1/2 being raised to now?
3.
A third. Need to be very careful with that one, guys. X is being raised to the,
3rd.
and y is being raised to the
9.
9th.
9.
Okay? You have to be very careful with that 1/2 to the third, guys, and we'll see why.
So we have to put that in parentheses as well.
Yep, just because we have to be extremely careful.
Awesome.
Because 1/2 to the third, how many 1/2s is that?
3.
1 over 2 times 1 over 2 times 1 over 2. Well, what's 1 over 2 times 1 over 2? 1 over 4.
1 over 6.
So what's 1 over 4 times 1 over 2?
1 over 8.
1 over 8.
1 over 8.
Yes.
Why is there someone over you?
So we have 24x squared y in the first parenthesis. Second parenthesis now 1 over 8, or 1 over 8, x cubed y to the 9th. Now what can we do?
Combine,
Multiply the parentheses together.
multiply.
Okay? So we do 24 times 1/8. Okay.
Put it over 1.
Yeah, put the 24 over 1. Can we cross simplify?
Yeah.
Yeah, what goes into both?
3.
Okay.
8.
8 goes into it, and 8 goes into 24 3 times, though, right? Is that what you're getting at? Yeah. Okay. So we end up having 3 over 1, or just 3. What do we have at following that 3?
X to the 5th.
X to the 5th
And Y to the 10th.
and y to the 10th. We add the exponents because we're multiplying the bases. Okay. Questions on that one? Let us continue. Let's get continuing to get this bread. Okay. We're gonna go through these last two actually a little bit quicker.
Speed round.
Okay, speed round. Okay. 5. Negative 3x squared times the quantity of 2y being squared.
Okay.
Okay. So our first step is to do what?
No.
Which exponent?
The 2 and the negative is 2x.
Okay. Which one?
2x. The x over 2. The x
Okay.
over 2.
Can we do anything with the exponent of x squared? No, we can't. What exponent can we do something with?
The y.
The 2y being raised. Okay. So it ends up being negative 3x squared. Then what?
Negative
No positive.
2y squared cubed. No, it is squared.
Justin?
2 squared and y squared.
2 squared y squared. We end up multiplying the exponent to those exponents inside.
Parentheses.
2 to the first, y to the first. Okay.
And your parentheses.
So end up multiplying 1 times 2 and 1 times 2.
Here's your parentheses.
Okay. So we could put parentheses around there if we want. Don't have to, but we could. We can still do the exponent. What is 2 squared? 4. Negative 3x squared, 4y squared. So what's this end up being?
Just that.
Whitney, what are you thinking?
I don't know.
Okay. What's negative 3 times 4?
Negative 12 and
Okay. And then, Whitney, how many x's do we end up with? Does it stay x squared or does it change?
Doesn't it stay x squared?
It does stay x squared. And then what about y?
It stays. That stays.
Stay the same. Y to the second. Yep. So we have negative 12 x squared y squared. Okay. Okay. Yeah, I get it. Okay. I want you guys to try out number 6. On number 6 here, negative x cubed y all being raised to the 4th. Can we do anything inside the parenthesis right now? Nope. Can we do anything with the 3 inside the exponent of 3? Nope. What can we do something with?
4.
Exponent of the 4. We're going to distribute that to the exponents inside. Now I want us to think of this as a negative 1 being raised to the first. A negative 1 being raised to the first times x cubed.
That just makes it more confusing.
Okay? Because that's going to help us with our signs. It's going to help us with our signs. See you, buddy. Okay? So we end up getting negative 1 being raised to the 4th. X being raised to the what? 12th. And then y being raised to the, Ben?
4.
Oh, 4.
4th. Okay? Now what is negative 1 to the 4th? Well,
Negative. No, positive 1.
that's negative 1 times negative 1 times negative 1 times negative 1. Well, negative 1 times negative 1 is
1.
1. Negative 1 times negative 1 is
1.
1 times 1 is
1.
1. So do you have to write it if we're multiplying by 1?
No.
No, we'll see that in a second. X to the 12th, y to the 4th, aka x to the 12th, y to the 4th. Now, if you guys didn't do the negative 1, did you still get the right answer here?
No.
Probably not, okay? Because you might have, you might not have, okay? Depending on how we did it. Okay, we have to be very careful that we also take this negative, okay? Now, what would have happened if this negative 1 was raised to the 3rd power?
It'd be negative.
It would have stayed negative, right? Okay? So we just have to be very careful with that. Any questions on that, guys?
No.
All right. Ms. Haswell, would you be willing to pass these out?
Absolutely.
Thank you so much. Okay, guys, on this worksheet we have today, that Mrs. Hazel's passing you guys right now, okay? Here's what I want. I want you guys to do the odds as well as 2, 4, 10, and then let's make Taylor Swift proud by doing 22. Okay? So I want you to do the odds as well as 2, 4, 10, and 22.